Hi, and welcome back to geology. So previously we have started talking about the history of the Earth, and I introduced to you some terms that are important, such as uniformitarianism, which is just the idea, let me kind of go back to it here, the idea that when we are looking at the way the rocks are laid as we can view them, we can just determine that the older rocks are on the bottom and the younger rocks are on the top. So kind of back to this picture here, older on the bottom, younger on the top. However, this is just a visual of sedimentary rocks, and clearly we already know about the rock cycle, so we know that there can be igneous and metamorphic intrusions and other types of things that can occur within these sedimentary rocks. And that's where we can start to incorporate what we call our intrusions. And so we went through that today, talking about the intrusions that are extrusive, meaning that they are inside the Earth's crust, and normally they are younger because you need to have those older rocks there first in order for them to intrude into or cut into, and that's where we came up with our idea of cross-cutting. And so then we went into and started talking about the idea of our folds and our faults, which can offset different types of rocks here. And so once again, we have our rock layer here. More than likely at one point these layers were flat, and then this fault, actually we can see the intrusion goes above the fault, so this is the youngest rock layer. And so these layers were here first. More than likely they got smushed together and became folded, and then the fault came through and offset them, meaning that this layer here should be connected here, this layer here should be connected here, but it's been shifted ever so slightly. And then we have our intrusion again. Woo, there we go. And so we're going to talk today just about our principles of the original horizontalization, or how we can look at what this all means. So sedimentary rocks normally form horizontally, layer by layer by layer. And so we talked about this when we looked at our sedimentary rocks, that you can have different types of erosional processes that then get compacted and cemented all in those sedimentary rocks. And this is called the principle of sedimentary rocks, state that undisturbed will remain horizontal, so they'll stay in those layers. So if it's tilt or broken, then that is due to some type of tectonic plate process. And so that this fault here and those folds, they were horizontal, and then tectonic plates caused them to become folded and other things. And so then that can also affect these processes that we talked about: graded bedding, cross bedding, and ripple marks. So once again, back to that term unconformity, we are going to, so in our uniformitarianism, we are going to look at 3 unconformities, which is just how did something get eroded or broken, or something looks different. And so we're going to use these 3 terms here today to kind of help answer those questions: angular, disconformity, and nonconformity. So unconformities in general are just a break in the geologic record created when sediments are deposited for a long period of time, meaning that we have your layers and then something happened to those layers, those horizontal layers, that cause them to do something different. So some type of plate tectonics or erosional freeze. So we're going to go through each one of these and kind of talk about what they look like. So our first unconformity is what we call angular conformity, and that just means that they've been tilted or moved upward or pushed upward. So an unconformity in which the beds below the unconformity dip at a different angle than the beds above it. We call this strike and dip in geology. And so this picture does a good job here. So here's our angular unconformity. More than likely at one point they were horizontal like this, but they got tilted upward. They got pushed upwards, more than likely due to some type of mountain building process, some type of plate tectonic. And then another environment came over top and deposited more layers. So we can see that break right here. This is our angular unconformity, meaning that this happened at some sequence. More than likely these continued on, and then an erosional process occurred to bring us down to this yellow line right here, and then these layers got deposited. So we can see this kind of in reverse here where these people are sitting. We can see our horizontal here, and then all of a sudden it gets pushed up. So this was a different sequence, a different time period, and then this one came over and got pushed up. And once again, we call that strike and dip. It's striking and dipping in a different angle than our horizontal beds. Our disconformity, as I like to think of it, is that something's been discontinued, if you want to think about it that way. An unconformity in which the beds above the unconformity are parallel to the beds below the unconformity. So that's a lot of words. What the heck does that mean? So let's think, like if this was our original rock series of horizontal layers, we have 1, 2, 3, 4. Something pushes these layers up. Let's say maybe a mountain building process, maybe some kind of magma chamber or whatever, which then pretty much erodes away layers 3 and 4. So uplift erosion of rock layers 3 and 4. So we're only left with layers 1 and 2. And it becomes kind of a jagged edge there. It's not this perfect break. You can see that some type of erosional processes occur. Well, of course, then more rock layers have the ability to form over top of this. And this is what this third column is kind of showing, is that all of a sudden then 6, 7 are now deposited on top of it. And so this break in between this layer 2 and layer 6 is what we call an unconformity, or I'm sorry, a disconformity. And so I like to think that those layers that were in between 2 and 6, so 3, 4, and 5, they were discontinued. They've been dissed out of this system, and now we're left with these different rock layers. But as you can see, like these have nice lines kind of to them. We can see that they just kept getting deposited and deposited and deposited. But some type of erosional process happened right here. Let it be a glacier. It could be maybe a tsunami came through, or it could even be some sort of just erosional process with wind, whatever it may be. This is our disconformity. It's been discontinued. The other one has to go back and do with our igneous formations, which is called a non-conformity. And I always think they do not comply, or they do not look like they belong. So an unconformity that separates profoundly different rock types, such as a sedimentary rock from a metamorphic rock. So these are our batholiths. These are our laccoliths. Any type of intrusion that kind of comes into contact with a large area. So just think these purple and yellow layers probably once were all there, and then all of a sudden this magma chamber came in. And it's not conformed with the rest of the layers. That's how I think about it. It's not conforming. It looks very different, and that's our non-conformity. And you can see that right here. There's a big bubble up right along here, and you actually can even see a fault right there. So we have our horizontal layers and then our big non-conformity at the bottom. Sometimes we can also have fragments that get stuck encased into another rock, kind of what we've talked about previously with igneous, is that you can have like different types of igneous rock trapped in other igneous rocks. Same things that can kind of help us figure out like these rocks are much younger than the surrounding older rock. And so once again, I just want to go back through these. These are our 3 different unconformities. And so we're going to be looking at slides to kind of help us figure out what unconformities are: angular, dis, and non. And one of the best examples of that in the U.S. is the Grand Canyon. And it's got several different unconformities that we can kind of take a look at. So once again, think about this would be the Colorado River running through the Grand Canyon. At one point, it was way up here, and it's cut down, 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 and down. And so as you can see, these terms over here, we're going to get to, we haven't yet: Permian, Pennsylvanian, Mississippi, Devonian, Cambrian, and Precambrian. These are different eras or periods in geologic history that we talk about. So for example, we normally fall, the Kentucky's rocks normally fall somewhere in here. So Precambrian normally means before life, Everything else after is afterlife, where we can find either our ancient sea creatures, dinosaurs, woolly mammoths, whatever it may be. But as you can see, there's a couple of our terms that we just talked about here. Is we've got unconformities, we've got angular conformities right here, and we don't have any. Actually, we do right here. We could call this one our non-conformity, where we have a igneous layer that's come up kind of towards the bottom of this river right here. But as you can see, that we have these angular conformities here, and then our unconformities is where we have these rock layers that are not as nice and crisp as some of these other ones, meaning that something happened, got it eroded away, and then these layers came and piled back on. And then we have another layer of erosion, and then these gut layers piled back on. And so the Grand Canyon, the river, did a wonderful job of kind of exposing all of these layers so that you can stand over here and look out and be like, wow, I can see all those different layers and see this angular, or you can see that something crazy happened right here and it doesn't form up in a nice layer or a sheet like it should. And so once again, this has to do with our relative age. We know that these rocks down here are older than the ones up here. And so now we're going to practice that.